In this video, we are going to find out how to solve multi-step equations involving combining like terms. Yeah, that's right. Let's do it. So how do we solve an equation like this where you have like terms involved? Well, basically the rule of thumb, and I'll tell you why this is that we need to combine like terms first or simplify everything that we can on both sides of the equation before undoing the order of operations. And the reason being is if I'm given an expression like this and I want to plug in a number, let's say, whatever my answer is, I would rather have one expression to plug the number into rather than two. Meaning, rather than plugging x equals 2, let's say, into both x's, I'd rather plug it into the combination of the two. So simplify as much as you can and then solve the order of operations backwards, as we've been doing with, let's say, two-step equations from past videos. Okay, so we're going to combine like terms. 6x plus 4x is 10x, adding them up. So you have 10x minus 17 is equal to 23. And let me make that equal sign a little more pronounced. There we go. Now, once you have this, you might notice, hey, that's an equation I've solved before. That's exactly right. We're going to undo the order of operations by adding 17 to both sides. Again, the most important part is that we confirm we've undone that minus 17 and then focus on 23 plus 17, which is 40. And that leaves us with 10x. 10x is equal to 40. How do we undo 10x equal to 40? Well, I'm going to undo multiplication by dividing by 10. And of course, I do that to both sides of the equation. We confirm we've undone 10 times x by dividing. It leaves us with x on its own. And 40 divided by 10 is 4. And of course, like usual, if you wanted to, you could do a check of your work by evaluating 4 into the original equation. You'd have 4 times 6 is 24. 4 times 4 is 16. Plus 24 is 40. Minus 17 is 23. Yes! All right, one more example of this sort. Here we have 8m plus 4 minus 10m equals 40. This is the kind of problem where students will often add 10m to get rid of the 10m over here and match it up with the 8. That you cannot do, right? That would be like me handing a $20 bill to somebody and saying, you know what, let's make this worth $40. And they're like, whoa, it's 20 because you're handing me a 20. Yeah, but let's just add an imaginary 20 to it. You can't just make something bigger without balancing it out, right? So in this case here, you can't just add 10m to the same side twice. That massively makes the side unbalanced. So what do? Well, really in your head, you should be thinking this is plus a negative 10m. And then again, this is next step. I do all of this in my head usually. So I'm looking at it like this mentally. I'm using the commutative property here to switch up the order. So mentally, I'm just saying 8m plus a negative 10m is negative 2m. And that is what this combines to be. So just be aware that that is the normal old rules of combining like terms. Okay, now from here I have negative 2m plus 4 equals 40. I want to undo the order of operations of plus 4. We've simplified everything as much as we could in the previous step, so we're ready to roll. That cancels out the plus 4, leaving us with negative 2m is equal to positive 36. And how do we undo negative 2 times a number? We divide by negative 2. And of course, we do that to both sides, keeping everything balanced. We confirm that we've got an m isolated by undoing the order of operations there. M is equal to 36 divided by a negative 2. We know our answer will be negative, and that'll be negative 18. And of course, if you plug your negative 18 into the m values and simplify everything out, guess what you'll get? A final answer of 40 and a check that says you are right. Great problems. Love them.